All right, in this question, we have this C-shaped bracket here, and we have a rectangular bar, as you can see here, that is connected to the bracket using two identical symmetrically placed rubber pads. So these are our two rubber pads. And when there's a load P applied to the rectangular bar, these two pads here transmit the load from the bar to the bracket by shearing deformation. So if this is the initial shape of the rubber pad, after we apply this load P, it will deform like this into a parallelogram shape, which is also shown here. Now in the first part of the question, the value of load P is given to us, which is 250 Newton, and the question wants us to determine the average shear stress in the rubber pad. In the second part of the question, using the shear stress that we calculated from the first part, and having the shear modulus of elasticity of the rubber, which is 0.6 megapascal, the question wants us to calculate the average shear strain. And finally, in the last part, based on the average shear strain that we calculated in part B, the question wants us to calculate this relative displacement delta that can be seen here in the rubber. Okay, so for the first part of the question, we can write average shear stress is equal to V divided by A. And if we draw the free body diagram of the bar from the side, we will have something like this. So we can write the equation of equilibrium in the x direction. Sigma fx is equal to 0. So 250 minus 2v is equal to 0. And this will give us a v equal to 125 Newton. And now this shear area would actually be this area here, which is W multiplied by B. So AS is W multiplied by B, or 0.080 meter multiplied by 0.050 meters, or 0.004 square meters. And now using this equation, we can write average shear stress is 125 divided by 0.004, or 31.25 kilopascal. Now for the second part, we can use Hooke's law for shear, which is shear stress is shear modulus of elasticity, which is GR multiplied by shear strain. So this was 31.25 kilopascal. This is 0.6 megapascal, or 600 kilopascal multiplied by gamma. So the shear strain would approximately be equal to 0.0521 meter divided by meter. And finally, for the last part, we can say tangent of gamma is equal to delta divided by 25 in this triangle shown here. And since the magnitude of this gamma is very small, we can use this approximation that tangent of gamma is approximately equal to gamma. So using these, we can say delta divided by 25 is approximately equal to gamma, or 0.0521. So delta would approximately be equal to 1.3021 millimeters. So if we apply a load of 250 Newton here to the rectangular bar, this rubber here will deform like this, and this value here would be around 1.3 millimeters. That's it. We calculated the shear stress in the rubber, and then average shear strain, and finally the relative displacement between the bar and the C-shaped bracket. Thanks for watching this video. Please subscribe to our channel if you haven't already. And if you like the video, press the like button. And if you have any comments or suggestions, please feel free to write for us in the comment section below. Thanks, and see you in the next video.